Hello, this is Professor Gill and welcome to Video 14B where we're going to talk about the basics of turning. So we just finished the basics of milling, so turning is the second most common process. So let's talk about turning, facing, and boring. So these are all the some of the processes that are done on the lathe. So this makes axisymmetric parts. Axisymmetric means that the part is symmetric about an axis. So a can or a ball or a bowl, anything where you could take a shape and rotate it around an axis to get the shape that you're cutting. Generally, we use single point cutting tools. So instead of having like a milling cutter where we'll have 5 or 6 teeth, we have a single point. And generally, the part rotates and the tool stays in the midplane of the part's rotational axis. So we have the part rotating now. Sometimes there's interrupted cutting, sometimes not. It depends on whether there are holes in the part or steps or slots or any pre-existing features. Also, when we start cutting, it's often not exactly centered, and so as we start cutting, the cut won't cut all the way around because the part isn't centered well. So if you have uninterrupted cuts, then that means that you get extremely long chips, and we'll do some calculations, I think, that will talk about the length of the chips, and they're surprisingly long. Anyway, so you have to do something to deal with those chips. Often that means that we put a chip breaker on the tool to cause that chip to fold in on itself and to shatter or to fracture. So there are 3 major processes in lathe work. This does not include drilling, so drilling is probably a 4th, but the ones that are specific to the lathe work. And so the first is turning, and that's where you're cutting the outside diameter of the axisymmetric surface. The second is facing. That's where you're cutting across the perpendicular end plane of the material, and that's generally perpendicular to the rotational axis. And then the third one that we have is boring, and boring is like turning, except you're on the inside surface of the part. So if you had a hole down the middle and you were cutting inside the part instead of outside the part, that's the difference between turning and boring. So these machines are defined by the number of spindles they have. So the ones you've been using in lab have 1 spindle on one end. But some machines can have 1 spindle on one end, and then after they've machined for a little while, they will hand it to a spindle on the other end of the machine so that you can work on the end that you couldn't see before. And so there will be sometimes several spindles. The number of tools that can be cutting at the same time or can be mounted in the machine. So the machines that you've been working on have 1 tool, but our CNC machines have up to 12 tools, and that's pretty common. And then if it has more than 1 tool, they're mounted in things called turrets. And some machines have 2 turrets, so they can cut with 2 tools simultaneously, and then some of them have more than that. And then we have flatbed or slant bed. So the lathes we've been working on in the lab are flatbed lathes. That means that the ways of the lathe, the thing that the table moves on, are horizontal. But you can also tip those up on an angle, and that reduces the size of the machine when you get into the big CNC machines to slant it up. It also allows you to get in there a little more easily to work on things. And then the rotational axis, whether it is horizontal or vertical, all of ours are horizontal, but you can get a vertical lathe. And then you can add little milling spindles in there and make what's called a mill turn machine. And the Mazak, which is a blue and gray machine that you walk past on your way into the lab, is a mill turn machine, and we will be getting a new mill turn machine pretty soon. So this is a manual engine lathe. It's called an engine lathe because it used to be driven by a belt from a steam engine. And so the engine lathe was one that you didn't have to crank on your own. And it also came to be known as one where the things can be driven. So the table can drive back and forth, or the crossfeed can be automatically driven back and forth. And so, but it's one that's driven by an engine rather than one that you had to pedal. So lathes are versatile, they're cost effective, they're everywhere, they're used a lot. You can do all sorts of things on them: turn, face, bore, drill, ream, thread, and cut off parts to length if they're axisymmetric. And so those are great things to be able to do. You can also do parts that are not axisymmetric and put axisymmetric features on them. So we do that sometimes as well. When we are doing turning and facing, as you can see here, this is turning the outside diameter of this large part, OD turning. So cutting the outside surface, it can be linear as you've been doing in lab, or it can be complicated. It can have lots of different steps, or it can have smooth shapes that you can make, sort of hourglass shapes or almost any shape. And we typically use the shortest, stoutest tool that we can to get a good surface finish. We'd like to really not have any deflection in this system, so that's why they're big, thick tools. When you're facing across the end, that also can be a linear move, or it can be complicated with steps and then curves and all sorts of things. And again, we use short tools, though often they can't be quite as short because they have to stick out a little bit to get to the end of the part. When you are doing boring, boring is terrifying. And there are a couple of reasons that it's terrifying. Well, it's cutting the inside of a part. So you have this giant boring bar, and this thing goes in and it's cutting this inside diameter on the part. Or you can see a little boring bar here going in and cutting inside the part. So again, it can have all sorts of shapes to it, curves, steps, angles, anything like that. So it requires tools that have a very long overhang. So you can see this thing has to be able to, this boring bar has to be able to stick all the way up inside the tool. And so it has to be pretty long because the tool has to be mounted way back out here. They are often have bad chatter and vibrations because the boring bar is so long. And so look at the size of this thing. This is a little tiny tool out here, and this thing looks like it's 8 or 10 inches in diameter to support that little tiny tool, and that's just to try to deal with vibrations and chatter and deflection that might be in there. And you have to be really careful in planning the boring because you can't see what's going on. So this is cutting inside this radius. If you think of an arc coming around and down here, it's really easy to have that arc hit right there on the bottom of the tool or down here on the bottom of the boring bar. And so you have to really plan that out well. Things that you think are going to work will often not work. And then you have to be really careful because you're machining inside where you can't see it. So as you go moving along the inside of the tool, you have to have planned it well because you can't watch what's going on. The parts of an engine lathe are shown here. Oops, sorry about that. So things that I would like you to know, one is the headstock. So the headstock is this entire end of the machine. It includes the spindle. So the spindle is the part that goes roundy round and holds the part. On the other end of the machine is the tailstock, so the head and the tail. The tailstock is this whole thing, and again we have a quill, just like we did in milling. And a quill is a part that extends around a rotational axis. So here this quill can extend, and many of you have put drill bits in them. You can also have a thing called a live center in there. We'll talk about that a little bit. Other parts of the machine. We have this part that travels along the axis. So if we think of the axes of the machine tool, we said for a mill, the axis that moves along the axis of rotation was Z, and so that is the same in a lathe. This is the Z axis back and forth. And so the part that moves along the Z axis is the carriage. That's this whole big thing. Sitting on top of the carriage is the cross slide, so that moves in and out in what we call X usually. And then there is often a compound rest mounted on top, and that compound rest can be set at any angle. It allows us to do angled cuts more easily than having to try to operate the carriage and the cross slide at the same time, which is pretty hard to do. So the things that I really, want you to know are the headstock and the tailstock and the carriage and the spindle and the cross slide and the compound rest. The apron is the piece that hangs down off the front of the carriage, and it has a lot of controls on it. So that's the apron. We have the quill, and then the tool post sits on top of the compound rest and holds the tool. So the other one that we don't have is the lead screw. So there is a long screw right here called the lead screw, and you can make it turn, and then there's a nut on the back inside the apron that you can engage, and then the carriage will move back and forth at the speed that you tell it to move, and so that allows you to do a really smooth cut, something better than what we've been doing in lab. So anyway, we have the carriage here, which moves in Z. We have here the cross slide, which moves in X, and then you can see the compound rest is set at about a 45-degree angle in this picture, but you can set it to anything. And then we have the tool post, which holds the tool. So that is the basics of lathes, and we'll talk about some specifics in the lab. Thanks for watching.